Hello everyone, in this video let's discuss about the Huffman coding or variable length coding. So if you are new to our channel, please subscribe for more engineering related topics. Now this Huffman coding or the variable length coding is used for the data compression technique. So what data compression technique does is, it makes sure that the less space or the less memory space will be used to transfer the data from the sender to the receiver, like that. Now, how to solve the Huffman coding or variable length coding problem is, we will be having only two steps. First step will be writing the frequency table. Frequency table. Now in frequency table, so the first column will be of the characters which are used in the bit frames. Next it will be of the frequency count. What is frequency count? How many times a character is repeated. How many times a character is repeated will be called as the frequency count. Next, another one will be Huffman coding. Huffman codes. So Huffman codes will be of the third column. So after writing these two columns, we will be jumping to the second step. After second step writing, we will be filling the Huffman codes right here. Now, what are the characters that are used in the given frame? A is used, B is used, C, D, E. So A, B, C, D and E are used. Now write the frequency count. That is how many times the characters are repeated. So if you see A, 1 time, 2, 3, 4 times. So A is repeated 4 times. Next B, 1, 2, 3, 4, 5, 6, 7. B is repeated 7 times. C, 1, 2, 3. So C is repeated 3 times. Next D, 1, 2. So D is repeated 2 times. Next E. So E is repeated 3 times. So another E is here. So E is repeated 4 times. So now we filled the two columns of the frequency table. That is the first step. Now let's move on to the second step. Later let's come and fill the Huffman codes for each of the characters. So in the second step, we will be drawing the Huffman tree. Huffman tree. So to draw the Huffman tree, what you must write is, first arrange the frequency count in the increasing order. Arrange frequency count. Arrange the frequency count in increasing order. So if you arrange them in increasing order, 2 is the least one. So 2, next it will be 3, next it will be 4, 4 and 7. Now, so which is the characteristic of frequency count 2? That is D. Next for 3 it is C. 4 you can write A or E. So let's write A and E first. Next F. Sorry, for 7 it will be of B. Now we wrote the corresponding characters for the increasing order of the frequency count. Now we must consider two frequency count. That is the least two frequency count. That is 2 and 3 of the characters D and C. So what we must do is, D will be written here and C will be written here. So from here we will be adding those. So what is the frequency count of D? It is of 2. Frequency count of C. So it is 3. So let's add it. So if we add 3 plus 2 is 5. 3 plus 2 is 5. Now we are updated with the value. So D and C combinedly forms the frequency count value as 5. So in the next step, what we will be doing? We will be writing again the frequency count in the increasing order. So 4, 4, 5, 7. This is the updated value for the D and C frequency count. So 4 is for A. Next for E also A. Next 5, D and C will be sharing the frequency count 5 and B will be of the 7. Now if you see, least two frequency count is of A and E, that is 4 and 4. So what you must do? Add them. So this is of A and this is of E. So this frequency count is 4. This is also having frequency count 4. If you add them, 4 plus 4 will be 8. Now one thing you must keep in mind. So as we move right side, the frequency count must increase. Frequency count must increase as we move right side. So here if you see 2, 3, 4, 4, 5, 8. So the increasing order of the frequency count is maintained here. Now here the updated value is 8 of A and E. Now in the next step what you must be doing, here if you see, so if you see the increasing order 5, 7, 8. So 5 is of D and C, next 7 is of B, and A and E will be sharing the frequency count of 8. Now the least 2 is 5 and 7, that is least frequency count is of 5 and 7. Now you must place 7 because 5 is already written. You must place 7 in a way that there must be the increasing frequency count when we traverse towards the right side. So I will be writing 7 here. So which node this is? This is of the B node. 7 means B node. If you see 5, 7, 8. This is in the increasing order. You just add these two. 5 plus 7 will be 12. So I said when we add the sum, it must be in the frequency count, must be increasing order. So if you see 12 is here, 8 is here. So the frequency count has decreased. What you must be doing is take this same subtree. Take this same subtree and keep this side. So 8 will be here, 4 will be here, and 4 will be here. This is of D and E. So this will be cancelled. So why I shifted this subtree to this side, that is left side, means if you see the frequency count must increase when we move this side. That is the sum value. So if you see the sum value, 8 is here and 12 is here. Both the sum frequency count is increasing when we move towards the right. Now we are left with, here there will be 12 now. So 5 plus 7 will be 12 and here 8 is there. If you see the increasing order 8 and 12. 8 is of A comma E and 12 is of D, C and B. So if you add both of them, 12 plus 8 will be of 20. 12 plus 8 will be of 20. Now we constructed the Huffman tree. Now using this Huffman tree, we will be constructing the Huffman codes for each of the characters. So how means, so if I consider a node here, when I will be traversing towards the right of that node, I will be giving 1. When I will be traversing towards the left of that node, I will be giving 0. So if you consider the 20 as a node, when I will be going towards the right side, I will give it as 1. When I will be going to the left side, it will be 0. So left side 0, right side 1. Left side 0, right side 1. Left side 0, right side 1. Here, A is here. So what you will be writing? So from root node to A, what you are using? 0 you are using to come to 8, and from 8 to come to 4 you are using 0. So 0 and 0 is the Huffman code for the A. Next for E. So 0 you are using up to 8, and from 8 to 4 you are using 1. So it will be 0 and 1. For E it is 0 and 1. Now let's write for D. So for D 1 0 0. For D it is 1 0 0. Next for C 1 0 1 1 0 1. For C 1 0 1. Next for B 1 1. For B the Huffman code is 1 and 1. So we have completed with the Huffman coding or the variable length coding problem. Only this much you must write in the examination. Hope you understood the concept of the Huffman coding or variable length coding. If you have any doubt, please comment below. If you liked the video, please subscribe for more engineering related topics. Thank you.